In this video, we'll be trying to solve the systems of linear equations using the concept of the determinants of a matrix. Okay, the question here says use determinants to solve the following systems of linear equations. The first one there, you have this, right? You have this is your first system of linear equation here. This is question 1, you have this, and then you have question 2, which is this. All right, so I'll solve question 1 and you solve question 2, leaving your answer in the comment section. All right, let's get to this, please. So solution, let's get to this solution. Now solution here, first things first, our task here would be to write out the given question. So for question 1, let me take this as question 1. Let's write out the given question. What I'm giving here is 3z minus 1, it's equal to x minus 2y. So I have this as 3z minus 1, it's equal to x minus 2y. The next one I have there is z minus 2x, it's equal to 3y minus 1. So I have that as z, this minus 2x, it's equal to 3y minus 1. The last set of equation I have there for question 1 is 2z plus 3x is equal to 8 minus 5y. So I have this as 2z plus 3x, it's equal to 8 minus 5y. So I have this. All right, so basically this is the first question. All right, I have this. So what's your first task here? I'll just come here, rule this, and then let's solve the first question. Okay. All right, so what's your first step in solving this question here? Your first step is in solving this question is to take all your variables to one side of the equation. I repeat, move all your variables to one side of the equation. If I look at the first equation there, which is this one here, observe that I have x and y on one side and I have z on the other side. So I want to move z to be in the same place with x and y. And if I do that, how do I do that exactly? What do I do? I'll move 3z over here. All right. Now notice that you have this as plus 3z. If I move 3z over here, it becomes minus 3z. So what you have here now becomes x minus 2y minus 3z. Okay. All right. So let's write that out. X minus 2y minus 3z. So I have this as x minus 2y minus 3z. That's the first thing there. Of course, you equate this to, remember that I move z from the left hand side to the right hand side. I'm still left with this term here, which is minus 1. So I'll equate that to minus 1. That's your first task. Okay. All right. Next to the next question there. The next question you have this one here. This one here. Now observe that x and z are on the same side. All I have to do is to move 3y over here. So I'll have y here. All right. In the arrangement, you arrange it in terms of x and then y and then z. So if I move 3y over here, this is plus 3y. If it moves over here, it becomes minus 3y. So if I arrange it in terms of x, y, and z, it becomes minus 2x minus 3y and then plus z. All right. So let me go and write that down. Right, so I have minus 2x, right? This one first, so it becomes minus 2x, and then you have minus 3y, minus 3y, and then you have plus z. So plus z, it's equal to, now I'm equating this to what there? Of course, if I move 3y over here, it becomes minus 3y, and in order of arrangement, I took the minus 2x first, minus 3y, and then plus z. Now what will be left there is equal to what there? Minus 1 again. Alright, so I'll be having minus 1 there. For this one here, I'll just write it here as minus 1. Okay, let's take the last one there. The last one, which is this. You're having x and z here. I simply have to move minus 5y over here. So it becomes what there? Plus 5y. And if I arrange this in terms of x, y, and z, it becomes plus 3x plus 5y plus 2z. Alright, you have this. And that will be equal to what there? 8, the number. Alright, so I can simply say that 8 is equal to both of them is still correct. All right, so I'll just come here and I'll say that 8. So 8 is equal to, you have 3x, so I have 3x, and then plus 5y, plus 5y, and then plus 2z. So I have plus 2z. Alright, so I've now arranged each of them in terms of x, y, and z. That's the first task. Alright, rearrange the systems of linear equation in terms of x, y, z. That's the first task. Alright, when you're done with that, what next? The next thing is that you want to make sure that your xyz terms are on the left hand side of the equation. Alright, then move the constant to the right hand side of the equation. Now we know that in mathematics, if A is equal to B, we can still say that B is equal to A. They mean the same thing. Alright, so this one can take this position and this one comes this way. Alright, it's mathematically correct. Right, so let's swap the position of the terms with the variable and the answers. So the first thing I have here is this one here. All right, I'll bring it first. That becomes x. I have x minus 2y minus 3z. That's the first thing there. And of course, it's equal to minus 1. So this would be equal to minus 1. Let's take the second term. Second term there is minus 2x minus 3y plus z. So I have this as minus 2x minus 3y plus z is equal to, that will be equal to, again, this one here, minus 1. That will be equal to minus 1. Finally, I have 3x plus 3y plus 5y plus 2z is equal to 8. So I have 3x plus 5y plus 2z is equal to 8. So I have this. So basically I have these information here, or I'm done rearranging. Alright, so after rearranging, what's your next step? Your next step here is to take the coefficient of x, y, and z and place them in one bracket to form your first matrix. Alright, the matrix is called the coefficient matrix. And how do you form the coefficient matrix? I've said simply take the coefficient of each of the terms. For x here, the coefficient here is 1. For y, the coefficient is minus 2. For z, the coefficient is minus 3. Alright, so I have 1, minus 2, and minus 3. So I'll go and write this down in the bracket. Alright, so this would now be 1, 1 minus 2, and then minus 3. That's the first one there. For the second one there, taking x, y, z, I have minus 2 of x, that's the coefficient, minus 3 of y, that's the coefficient, and then plus 1, or just 1. So I have minus 2, minus 3, and then 1. Alright, so I'll go and write this as minus 2, minus 3, and 1. Then finally for this one here, you have the coefficient of x as 3, for y as 5, for z as 2. So I have 3, 5, 2. Alright, from here, this becomes 3, this becomes 5, this becomes 2. Alright, so with this, I've written the coefficient matrix. Alright, then the next thing you have to do is that you multiply this with the variable matrix. Alright, so it would form the variable matrix. So let's multiply this with the variable matrix. How do you form the variable matrix? Looking at the question here, the variables are x, y, and z. So I have this as x, I have this as y, I have this as z. So it's just this simple. Okay. Alright, so you have this. This would now be equal to, then if the last bracket or the last matrix you have to form is called the answer matrix. Alright, so all your answers, list them in a particular bracket. Here I have minus 1, and 8. So I would come here and put this as minus 1, and then 8. Alright, so with this, we have now formed our first bracket. Alright, so we have this. Alright, so what's the next procedure from here? Your next step is that you call this coefficient matrix, you call it lambda. Alright, so you say lambda is equal to this particular coefficient matrix. So let's go and write that one out there. So we'll say from here. Alright, so first things first, I'll write out the coefficient matrix. We had that as 1, minus 2, minus 3. We had minus 2, minus 3, 1. We had 3, 5, and 2. And we said we'll call this lambda. So this one here, let's call this lambda. So I'll say let lambda be equal to this. So we have this. All right. Now, when you're done with this, your next step is to find the value of the determinant of lambda. All right. So I will say the determinant. The right determinant is simply this. Determinant of lambda, does this, is equal to. Now, of course, to get determinant of a 3 by 3 matrix, you simply add your plus, minus, plus sign. All right. We've treated this in our previous class on matrices. I'll leave a link in the video description. From this here, the first thing you have there is plus 1. So I have plus 1 here. So that becomes plus 1. So I have this as plus 1 into, for plus 1, if I cover the rows and column, I'll cover the row of this, that's a 1. I'll cover the column of 1. What you have there is, you have this as minus 3152. Alright, so I'll just take that down. Minus 3152. You have minus 3152. That's the first thing there. After plus 1, the next thing you take this and this. So what you have here becomes minus minus 2. Alright? Minus minus 2 gives you plus 2. That becomes plus 2 into, for this also I'll create this for 2. Let's cover the row and column. I'll cover the row of this and also the column of this. So what I have there now is minus 2, 1, 3, 2. All right, let me do that now. So I'll take that as minus 2, 1, 3, 2. So minus 2, 1, 3, 2. That's plus 2. And then finally you have plus minus 3. Plus minus gives you minus 3. So it becomes minus 3 into, so minus 3 into, what do we have there? For minus 3, again, cover the row of minus 3, that's this. Cover the column of minus 3, that's this. You'd have this as minus 2, minus 3, 3, and 5. Alright, let's go take that down. Minus 2, minus 3, 3, and 5. Minus 2, minus 3, 3, and 5. So you have this one here. Alright, so we have this. This is the value of determinant of lambda. With this, the next thing we have to take is also, that means the determinant of lambda is equal to, you have plus 1. Now to solve this, all you have to do is multiply these two terms, this and this, right? The one on your right hand side, all right? This is called the right diagonal, also called the principal diagonal. Multiply them. Minus 3 times 2 gives you minus 6. Then subtract it from, multiply the terms on your left diagonal. That becomes 1 times 5, which is what? 5. Next up, plus 2 into, repeat the same process. Don't forget the diagonal on the right hand side, which is this 2 here, which is minus 2 times 2. Multiply them, that gives you minus 4. Then minus, multiply this other 2 there. 1 times 3, which is 3. Okay. Next up again, I have minus 3 into, multiply the diagonal on the right hand side, this one here. That becomes minus 2 times 5, which is minus 10. Then minus, multiply this other one here, which is minus 3 times 3, which is minus 9. Alright, so it's minus, then minus 9. Please observe that. Alright, let's proceed with this. That means the determinant of lambda, so I call this determinant of lambda, is equal to, I have plus 1 into minus 6 minus 5 gives you minus 11, plus 2 into minus 4 minus 3 is minus 7, minus 3 into, if I solve this, I have this as minus 10 minus minus 9. So minus minus gives you plus 9. Okay, so minus 10 plus 9 gives you minus 1. So I have this. All right, let's solve this and see what we get. From here, this will be equal to 1 times minus 11 gives you minus 11, plus times minus gives you minus, 2 times 7 is 14, minus times minus is plus, so plus, 3 times 1 is 3. This becomes the determinant of lambda, and that's equal to, if I punch this, minus 11 minus 20 minus 14 gives you minus 25, minus 25 plus 3 gives you minus 22. So I have this as minus 22. That means the determinant of lambda, can say determinant of lambda is equal to minus 22. So we have this. All right, that's our first task. Now, the next thing you want to get is something called lambda x. We want to get lambda x. Now, how do we get lambda x? Coming back to my first matrices, this one here. To get the value of lambda x, all you have to do is to replace the first column. By column, I mean this one here. This is the first column, all right? Replace the values of the first column by the answer matrix. If I do that replacing, I would have that. That means for my new matrix, I will take out all the values of this one here, replace this by the answer matrix. So what would it look like? Let me write it here first so you get a clear picture. If I write it here first, I'll be having this as minus 1. Okay, so this one is coming here, right? It becomes minus 1, and then 8. So basically, this is what you have, okay? But let me write this separately so I don't get everything mixed up, all right? So, so I have this. So let me replace it there. So I would have something that looks like minus 1, 8. And then you can now repeat these other two guys, these other two columns. Minus 2, minus 3, 5. So I have this as minus 2, minus 3, 5. And then finally I have minus 3, 1, 2. So I have this as minus 3, 1, and then 2. This is what we call lambda x. So I have this as lambda x. So to get lambda x, all you have to do is to replace all the terms of the first column by your answer matrix. That's the concept, all right? All right, let's go and write this down here. So this is the value of lambda x. I will take this value and write it out there, okay? All right, for lambda x, I'll come here, I'll say for lambda x, we said that lambda x is equal to, the value there was given as, or we got as minus 1, minus 2, minus 3, minus 1, minus 3, 1, 8, 5, and 2. All right, so let's encase this in brackets. So this and this is what we call lambda x. So lambda x is equal to this, all right? Now let's get the determinant of lambda x from here. Let's get determinants. So determinant of lambda x, all right? How do you get this? What do you do? Again, your first task is to add plus, minus, plus, all right? So it becomes, the first thing I have there is what I have here, plus minus 1. If you punch plus minus 1, you get minus 1. So you can write minus 1 as just minus, or you can put minus 1, but this is not proper. So I'll just write it as minus, and then your next task is to cover the row and the column. For this one here, cover the row of this and the column of this. What do you have there? Minus 3, 1, 5, 2. So let's take that down. Minus 3, 1, 5, 2. Minus 3, 1, 5, 2. I have this. Take the next one there. I have, look at this, minus minus 2. Minus minus 2 gives you plus 2. So I have plus 2 into, for 2, again, cover the row and column. I'll cover this row, I'll cover this column. So it becomes minus 1, 1, 8, 2. All right, let me take it down. Minus 1, 1, 8, 2. I'll come here, minus 1, 1, 8, and then 2. So you have this one here. Okay, what's next in there? Next in there is this plus minus 3. Plus minus is minus, so it becomes minus 3. So having minus 3 into, for this one here, let me open this first. So let's go close the row and column for minus 3. If I close the row of minus 3 and the column of minus 3, you can see that I have this as minus 1, minus 3, 8, 5. So let me take that down. Minus 1, minus 3, 8, 5. So this is minus 1, minus 3, 8, and then 5. I have this. Alright, so I have this now. Okay. Minus 1, minus 3, 8, 5. Alright, so let's solve this. From here, we'll have that determinant of lambda x is equal to, this becomes minus, don't forget the step, we said multiply the terms on your principal diagonal, that's for the right hand side. That becomes minus 3 times 2, which is minus 6, then minus, multiply this other 2 there. 1 times 5 is 5. I'm done with this. Then take plus 2. So plus 2 into, repeat the same process, multiply the terms on your principal diagonal. Minus 1 times 2 is minus 2 minus 1 times 8. It was there, 8. Finally, minus 3 into, for minus 3, do the same thing there, multiply the terms here. Minus 1 times 5, that's minus 5. So it's always your principal diagonal first before the other one. Then this minus 3 times 8 is minus 24. So I have this. All right, let's get this done. So I have that lambda x, or determinant of lambda x, is equal to minus 6 minus 5 is minus 11. Okay, plus 2 into minus 2 minus 8 is minus 10. Minus 3 into, next thing I have here is minus 5. Minus 24 gives you plus 24. So minus 5 plus 24, that gives you 19, or plus 19. All right. All right, so I have this. Let's proceed with this. So with this here, from here I have that determinant of lambda x is equal to, all right, minus 11 gives you plus 11. Plus 2 times minus 10 gives you minus 20. And then finally you have minus 3 times 19. If you punch minus 3 times 19, what you have there is actually minus 57. So minus 57. Let's get this done. So if I punch 11 minus 20 minus 57, you have your answer as minus 66. Alright, you have your answer as minus 66. So you have this. Alright, so with this now we can say that lambda x, alright, with this we can say that lambda x, so we can have the lambda x. So therefore, lambda x is equal to minus 66. We've gotten the value for all the determinants, please. Determinant of lambda x is equal to minus 66. Let's now get the value of the lambda y and also the determinant of lambda y. Alright, so proceeding with this, I'll just go out and write the value of lambda and lambda x. Alright, I would come here, right? We got that for lambda, the determinant of lambda, we got the value as equal to minus 22. We got the value of the determinant of lambda x, we got this as equal to minus 66. All right, let's find for lambda y as well as lambda z. Okay, so I'll just take these ones off. All right, now to get the value of lambda y, all you have to do is to replace the second column. Now we said for lambda x, replace the first column. For lambda y, replace the second column. That's all of this with the value of your answer matrix. All right, and if I do that, what do I have? So the first thing is that I want to write out the first column there. My first column is simply 1 minus 2, 3. So I have 1 minus 2, 3. Replace this one here with the answer matrix, which is minus 1, minus 1, 8. So I have minus 1, minus 1, 8. And then replace the last column here, or rewrite the last column. Minus 3, 1, 2. So I have this as minus 3, 1, 2. So I have this. This value here is equal to lambda y. Alright, so this is what you have as lambda y. 1, have this as 1 minus 1 minus 3. Minus 2 minus 1, 1, 8, 3, 8, 2. Alright, so let's take this down. Alright, so we have that. I'll just write this down. I'll write this as, for lambda y, I have 1, minus 1, and minus 3. I also have minus 2, minus 1, and then 1. Then you have 3. Then you have 8. And then you have 2. Alright. Alright, so I'll take this here, cover this up, and also cover this up. This is the value of lambda y. So let lambda y is equal to this. Or you can say for lambda y, say lambda y is equal to this. Let's get determinant. So determinant of lambda y, determinant of lambda y is equal to simply determinant of this matrix. I'll come here, put this here to this point here. This is 1 minus 1 minus 3, 1 minus 1 minus 3. Then you have minus 2 minus 1, 1, minus 2 minus 1, 1. And then you have 3, 8, 2. That's 3, 8, and then 2. So you have this. Okay, from here, let's take the determinant of this matrix, and this is equal to, so determinant of lambda y, it's equal to, of course, first things first, you have plus minus plus. So you have plus 1. Plus 1 is the same thing as me just writing plus. If I write plus here, it simply means plus 1. I would come here, open this up. So plus into, for plus 1, cover the row and the column. You're left with what's there? Minus 1182. Alright. So I have this as minus 1182. Alright, so you have this. That's the first one there. Next up, you now have this one here, which is minus minus 1. Minus minus 1 is plus 1. So it becomes t plus. Alright, you don't have to write the 1, it's just plus. Plus means plus 1. Again, cover the row and column for this. So the row for this and then the column for this. You're having this as minus 2, 1, 3, and 2. Alright, minus 2, 1, 3, and 2. Alright, minus 2, 1, 3, and 2. Alright, the last one there, for the last one here, which is this, cover the row of this and the column of this, you have minus 2 minus 1, 3, 8. Alright, minus 2 minus 1, that's minus 3. Alright, let's see. Yep, plus minus is minus 3. Then when you cover that up, you have minus 2 minus 1, 3, 8. This into minus 2 minus 1, 3, and 8. Alright, so you have this. So this is equal to, this is plus into, again, multiply this 2 here. Alright, so that becomes minus 1 times 2 minus 2 minus 1 times 8 is 8, plus, again, for the next one there, it becomes minus 2 times 2, that's minus 4, then minus 1 times 3, that's 3, then finally minus 3 into minus 2 times 8 is minus 16, and then minus 1 times 3, or minus, then minus 1 times 3 is minus 3. So we have this. All right, let's work on this. So from here, this is the determinant of lambda y, all right? Determinant of lambda y, and that's equal to plus minus 2 minus 8 is actually minus 10, plus, next up you have minus 3, minus 4 minus 3 is minus 7, okay? And then minus 3 into, next up we have minus 16 minus minus 3. Minus minus 3, these two would give you plus 3. So it becomes minus 16 plus 3, which is minus 13. Alright, let's work on this. This is equal to, we have this of y, determinant of lambda y is equal to, this is plus minus is minus 10, plus minus 7 is minus 7, minus 3 times minus 13. Minus times minus is plus, 3 times 13 is 39. Alright, so let's punch this. If I punch this, what do I have here? I have this as minus 10, minus 7, plus 39, and I have this as 22 as my answer. Alright, so lambda y is 22. So this is 22. So we can say that therefore, determinant of lambda y is equal to, determinant of lambda y is equal to 22 or positive 22. Alright, okay, let's proceed with this. Okay, so finally, let's get lambda z, all right? So going back to the initial question, which is this, all right, let's get sigma z. I'll just take this off. So of course, to get the value of lambda z, okay, so to get the value of lambda z, all I have to do is to replace the last column, all right? Replace the last column by the answer matrix, that's all. All right, so I'll just come here and write this 1 minus 2, 3, which is this. Then minus 2 minus 3, 5. So I have this as minus 2 minus 3 and then 5. Finally, replace the last column by minus 1 minus 1, 8. So I have this as minus 1 minus 1, 8. So I have this. So this will be equal to lambda z. All right, so I have lambda z as 1 minus 2 minus 1 minus 2 minus 3 minus 1 and then 3, 5, 8. Okay. All right, so I'll go and look for the determinant of this. Okay. So I'll come here and write for lambda z. Now for lambda z, what do you have there? We'll have that lambda z, as we said, it's equal to the matrix there for lambda z is 1 minus 2 minus 1 minus 2 minus 3 minus 1. Then you have 3, 5, 8, 3, 5, and then 8. So I'll take this in a matrix, and then of course I'll have to find determinant of this matrix. All right, so let's get determinant of lambda z. All right, so from here, let me just rule this here. So I'll have the determinant of lambda z, it's equal to, what are the determinants there? First things first, take plus minus plus. So you have plus 1, all right? I have plus 1, which is something as plus. So I have this as plus. For this, cover the row. Before then, let me create this. All right, so for this, cover the row and column. So I cover the row of this, and I cover the column of this. What I have here becomes minus 3 minus 1, 5, 8. All right, so I'm write out that. Minus 3 minus 1, so minus 3 minus 1, 5, 8. So I have this. Next up, you now have the second thing there, which is minus minus 2. Right? Minus minus 2 gives you plus 2. So I have this as plus 2 into, for plus 2, I'll cover this and also cover this. Now for plus 2, cover the row and column of this. So the row of this and the column of this. What I have there is minus 2 minus 1, 3, 8. Okay? Minus 2, minus 1, 3, and 8. Then finally you have plus minus 1. That's this. Plus minus 1 gives you plus minus 1. Plus minus 1 gives you minus 1. And that becomes simply minus. And I'll open this again. So minus, cover the row and column. For that becomes the row is off, the column for this. So I have minus 2, minus 3, 3, and then 5. Minus 2, minus 3, minus 2, minus 3, 3, and then 5. So I have this. Let's get the value of this. So we have that determinant of lambda z, it's equal to, I have plus into minus 3 times 8 is minus 24, minus 1 times 5 is minus 5. Proceeding, this becomes plus 2 into minus 2 times 8 is minus 16, minus 1 times 3 is minus 3. Okay, then minus into minus 2 times 5 is minus 10, minus 3 times 3 is minus 9. So I have this. All right, let's get this done. So what do we have here? We have that this as determinant of lambda z, it's equal to plus, this is minus 24, minus 5 is plus 5, so it becomes this plus 5. Okay, so what we have there is minus 24 plus 5, plus 5, plus 2 into, what we have here becomes minus 16, minus is plus, so plus 3, and then minus into minus 10 minus minus gives you plus 9. All right, let's proceed with this. This is equal to plus into, so that's plus into, in my bracket there I have minus 24 plus 5, and that gives you minus 19. So I have minus 19. Next up you have plus 2. So plus 2 into, what do I have there? Minus 16 plus 3, that's minus 13. This gives you minus 13. Okay. And then minus into minus 10 plus 9 gives you minus 1. All right, so let's solve this. What do we have here? So I'll just pick up my calculator and punch directly. All right, so let me pick my calculator and I'll punch this directly. So plus, open a bracket, type minus 19, close the bracket, type plus 2, open a bracket, type minus 13, close the bracket, then minus, open a bracket, minus 1. If you type all of this, your answer gives you minus 44. So you have this as minus 44. All right, so you can type this in a calculator. You have minus 44. So therefore, we can say that the value of the determinant of lambda z is equal to minus 44. All right, so if you have this value, we can now proceed to find the value of x, y, and z. All right, if you have this value, all right. Now to get the value of x, note that x will be equal to the determinant of lambda x, this all divided by the determinant of lambda. That's how to get x. And that's equal to determinant of lambda x. Let's see the value. What did we get there? We got the value there as, let's see, look at this, minus 66. All right. So I'm going to take minus 66. I'll bring it here. And let's see. That becomes minus 66 all over, we got this value as minus 22. And if I do that, this cancels this, that's equal to 3. So you can say that therefore, so x, it's equal to 3. We have this. To get y, similarly, we'll say that y, it's equal to the determinant of lambda y, this one here, all over the determinant of lambda. And that's equal to, for lambda y, the value was what there? 22. So that becomes 22 all over, determinant of lambda is minus 22. And if I work on this, 22 divided by minus 22 gives you minus 1. So we can say that y is equal to minus 1. Let's get z. Now for z, we'll have that z is equal to the determinant of lambda z all over determinant of lambda, and that's equal to determinant of lambda z. What do you have there? Minus 44. Okay, so this becomes minus 44 all over minus 22. Minus cancels minus, 22 here 1, 22 here 2. So that's equal to 2. So therefore, what's the value of x, y, and z? Therefore, we can say that x is equal to 3, y is minus 1, and z is 2. So therefore, x is equal to 3, y is equal to minus 1, and z it's equal to, your value is 2. All right, so 3, y is minus 1, and z is 2. All right, so this is how you solve this question. All right, so you can put in these values of x being equal to 3, y minus 1, and z equal to 2. You can put these values back into the original equation. That's this. All right, if you put them back into this particular equation, that's this one here, you'll see that this, the left hand side will be equal to the right hand side, and that proves that your answer is correct. All right, so that's how you verify that your answer is correct. When you're done putting those values into all of this equation, and they should be correct, so that proves that your answer is correct. I'll just do one of this. Let me take this first one here. I'll just take just the first one. You can check out the other one later. All right, you have 3z minus 1, that becomes 3 into, we got z as 2, 3 into 2 minus 1, it's equal to, then we have x, right? We got x as 3, that's 3 minus 2y, minus 2 into, we got y as minus 1, so minus 1. If I look at this, 3 times 2 is 6, right? That becomes 6 minus 1. 6 minus 1 is 5, is equal to, this becomes 3 into minus 2 times minus 1 gives you plus 2, plus 2 plus 3 gives you 5. So you can see that the left hand side and right hand side, they are equal. That means your answers are correct. Okay, so that's how you do, that's how you verify. You can also try it with also these other two equations and you have the same thing. All right, so that's how we solve this question. All right guys, if you enjoyed this video as usual, do well to hit the like button, like this video, leave a comment. If you have any question, leave it in the comment section and I'll attend to them. Don't forget to also subscribe. If it's your first time here or you're yet to subscribe, please do well to subscribe, hit the bell icon and select all so that you get notified whenever we upload a new content. Then finally, share this video to your friends so that they can also learn. Do well to visit my website www.jonahimmanuel.com/courses to check out the available courses, and also visit www.jonahimmanuel.com/books to see any of the available books. All right. Do well to register an account to the website, and then you can now proceed to get any of the available courses or books. Thank you and see you in our next class.